Welcome to this lecture on Agentic Frameworks. In this session, we're going to explore what Agentic Frameworks are, when you actually need one, and the key components that make them work. By the end of this discussion, you'll have a solid understanding of why these frameworks exist and how they help in building powerful AI-driven applications. Let's start with a simple question: what exactly is an agentic framework? Think of it this way. Whenever you interact with an AI-powered system, whether it's a chatbot, a virtual assistant, or even an AI-driven research tool, there's usually some structured way that the AI processes your request, reasons about it, and then takes action. This structured approach is where agentic frameworks come into play. An agentic framework is a system that helps build AI agents, giving them the ability to make decisions, take actions, and interact with tools or external environments in a dynamic way. These frameworks serve as a foundation for AI models, particularly large language models, LLMs, allowing them to go beyond simple text generation and actually perform real-world tasks like searching the web, executing code, or interacting with APIs. In other words, agentic frameworks provide the structure that lets AI act more like an independent problem solver rather than just a text generator. Now, you might be wondering, do you always need an agentic framework when working with AI? The short answer is no. Let's break it down. There are plenty of cases where a simple approach is enough. If your application only requires a fixed set of responses or follows a straightforward pattern, like answering frequently asked questions or running a predefined set of commands, then you don't necessarily need an agentic framework. In such cases, a basic LLM-powered chatbot or a simple chain of prompts might be sufficient. However, as soon as your AI system starts needing more flexibility, things get complicated. Let's say you want your AI to call external tools or functions dynamically, or search for information and synthesize answers on the fly, or make decisions based on changing inputs, or coordinate multiple steps or agents to complete a task. Once you start introducing these complexities, an agentic framework becomes extremely useful. Instead of manually managing all the logic yourself, the framework takes care of structuring how the AI reasons, interacts with tools, and processes information. So, in other words, you should consider using an agentic framework when your workflow involves multiple steps or decision-making beyond just simple text generation. Or you want your AI to interact with external systems like APIs, databases, or tools. Or you need more flexibility in handling different types of tasks without hard-coding everything. Now that we know when agentic frameworks are useful, let's talk about what actually makes up an agentic system. What are the moving parts that allow an AI to operate intelligently within a structured framework? At a high level, an agentic system consists of several key components that work together to enable decision-making and action execution. These include an LLM engine. This is the core of the system, the AI brain that generates responses, makes decisions, and processes user input. The LLM powers the reasoning ability of the agent. A list of tools. Tools are the functions or external resources the agent can interact with. For example, an agent could have tools for retrieving web search results, executing Python code, or even controlling a robotic system. A parser for extracting tool calls. Since an AI doesn't inherently know how to use external tools, a parser is needed to interpret when the LLM is requesting to use a tool, and then execute it accordingly. A system prompt. This is a predefined set of instructions that guides the AI on how it should behave. It ensures that the AI stays aligned with the intended task and interacts correctly with tools. A memory system. Some agentic applications need to remember past interactions to maintain context. This could be a short-term memory for a single session or a long-term memory for ongoing user interactions. Error logging and retry mechanisms. Since AI models aren't perfect, agentic frameworks often include error handling. If something goes wrong, like a tool failing or an unexpected response, there needs to be a way to detect the issue and either retry or adjust the approach. Each of these components plays a critical role in allowing an AI agent to function effectively within a given framework. Together, they enable the AI to not just generate text, but to think, reason, and take meaningful actions in a structured way. We'll now take a closer look at Smolagents, a lightweight agentic framework that simplifies AI development while still offering these powerful capabilities. So, what is Smolagents? At its core, Smolagents is a simple yet powerful framework designed to create AI agents with minimal complexity. Unlike other agentic frameworks that can be heavy and require extensive setup, Smolagents is lightweight, making it a great option for developers who want to quickly experiment with AI agents without dealing with unnecessary overhead. Think of Smolagents as a toolbox that helps you build AI agents in a clean, modular, and efficient way. Instead of writing long, complex scripts to control how an AI interacts with the world, Smolagents provides a structured way to define agents that can think, observe, and act. Here's what makes Smolagents stand out: it is lightweight and flexible, it doesn't require complex configurations, making it easy to set up and use. It integrates seamlessly with LLMs, works with Hugging Face models, OpenAI's GPT, and other AI models. And supports real-world interaction. The AI agents built with Smolagents can search the web, generate code, and perform tasks beyond just text generation. So instead of just responding with information, Smolagents allows AI models to actively solve problems by taking actions in the real world. A traditional LLM takes an input, generates a response, and stops there. But what if we need the AI to do something more than just answering a question? For example, let's say we want an AI assistant to search the web for the latest stock prices. And generate Python code and execute it. And summarize a document from an online source. A basic language model can't do these things on its own, as it can only generate text. That's where Smolagents comes in. With Smolagents, an AI isn't just generating responses, it's performing actions. The framework allows an agent to call external tools, interact with APIs, and process real-world information. This makes it much more powerful than a standard chatbot. So, how exactly does Smolagents allow AI to take actions? It follows a simple but effective cycle based on three key concepts: the thoughts, the AI thinks about what it needs to do. Observations, it looks at relevant information or results from previous steps. And actions, it takes an action, like calling a tool or executing code. Let's go through an example to see this cycle in action. Imagine we have an AI assistant called Alfred, who is helping organize a party. If we ask Alfred, what's the best way to send invitations, here's what might happen. Thought: Alfred thinks, I should check what tools I have for sending invitations. Observation, it checks and sees that it has access to an email sending tool. Action: Alfred generates and sends an email invitation to all guests. This process allows the AI to reason through the problem, use available tools, and take meaningful action, all while adapting dynamically based on observations. Instead of just responding with, "You can send invitations via email," like a normal chatbot, an agent built with Smolagents can actually send the invitations for you. The ability to think, observe, and act is what separates a passive chatbot from an intelligent AI agent. Traditional LLM-powered applications are limited because they can only respond with static text. Can't take action without external code. Require human intervention for execution. Smolagents breaks this limitation by giving AI the ability to interact with external systems such as APIs, databases, web search. Make decisions dynamically based on real-time information. And automate complex workflows by chaining multiple actions together. This makes Smolagents an excellent choice for developers who want to build smarter, more capable AI agents without unnecessary complexity. Now that we understand what Smolagents is and how it enables AI agents to take meaningful actions, let's explore some of its key advantages. Unlike many other agentic frameworks that come with heavy abstractions and complex setups, Smolagents takes a minimalist, code-first approach, making it an excellent choice for developers who want to quickly build and experiment with AI agents. There are four main advantages that make Smolagents stand out: the minimalistic design with low-code complexity. It works with any LLM via Hugging Face and external APIs. It has code-first approach, which generates executable Python code, and seamless integration with Hugging Face Hub for easy tool usage. Let's go through each of these in detail. Minimalistic design with low-code complexity. One of the biggest strengths of Smolagents is its simplicity. Many agentic frameworks require extensive setup, defining multiple components before an AI can function properly. But with Smolagents, you can build a working agent with just a few lines of code. This minimalistic design means that developers don't have to deal with unnecessary abstractions. The framework is easy to understand, modify, and extend. And you can quickly test new ideas without getting stuck in complex configurations. Some agentic frameworks force you to define rigid workflows, requiring custom JSON formats, predefined tool structures, and intricate parsing mechanisms. While this can be useful for highly structured applications, it slows down development when all you need is a simple, functional agent. Smolagents, on the other hand, follows the principle of minimalism by keeping things as simple as possible while still being powerful enough to build advanced agents. So, if you're looking for a lightweight, developer-friendly framework that doesn't overcomplicate things, Smolagents is a great option. Second, Smolagents works with any LLM via Hugging Face and external APIs. Unlike some frameworks that lock you into a specific LLM provider, Smolagents allows you to use any large language model that meets the basic integration requirements. This means you can connect Smolagents to Hugging Face transformers for open-source LLMs like Llama, Mistral, and Falcon. Or OpenAI models like GPT for using API. Or Azure OpenAI services if you're working in a cloud-based environment. Or even local LLMs running on your own infrastructure. The framework provides built-in support for different model types, making it easy to swap between models without rewriting your entire codebase. This is especially useful if you're experimenting with multiple models to find the best fit for your application. For example, if you're building an AI research assistant, you might start with OpenAI's GPT models but later decide to switch to an open-source model for privacy reasons. With Smolagents, this transition is smooth because the framework is designed to be model-agnostic. This level of flexibility makes Smolagents a future-proof choice, giving you the freedom to choose the best LLM for your needs rather than being locked into a specific vendor. Third is code-first approach. One of the most unique aspects of Smolagents is its code-first approach to agent execution. Instead of forcing developers to work with JSON-based actions, Smolagents directly generates Python code that can be executed immediately. Why is this important? Let's break it down. In many other agentic frameworks, AI agents don't actually execute actions directly. Instead, they output JSON or structured text, which must then be parsed and converted into actual function calls. This adds an extra layer of complexity and slows down execution. Smolagents bypasses this step entirely by generating directly executable Python code. This means no need for parsing or extra processing. The output can be executed instantly. More control and transparency over what the agent is doing. And easier debugging since the agent produces human-readable Python code. This makes execution faster, simpler, and more intuitive. It also allows developers to inspect, modify, and even manually execute the agent's output if needed. By embracing a code-first philosophy, Smolagents removes unnecessary steps, making it one of the most developer-friendly agentic frameworks available. Fourth is seamless integration with Hugging Face Hub for easy tool usage. The final key advantage of Smolagents is its tight integration with the Hugging Face ecosystem. Hugging Face is one of the largest AI model and tool repositories, offering pre-trained models, datasets, and AI tools. Smolagents leverages this ecosystem by allowing users to use tools hosted on Hugging Face spaces without complex setup. Leverage community-contributed AI functions to expand their agents' capabilities. And easily share and reuse tools across multiple projects. For example, if you want your agent to perform image generation, you don't have to build a tool from scratch. Instead, you can simply connect it to a Hugging Face tool that already does the job. This makes it easy to extend the capabilities of your AI agent without reinventing the wheel. This integration also means that Smolagents can evolve quickly, benefiting from the latest advancements in the AI community. Since new tools and models are constantly being added to Hugging Face, Smolagents users can access cutting-edge AI capabilities with minimal effort. These advantages make Smolagents an excellent choice for developers who want to quickly build, test, and deploy AI agents without unnecessary complexity. Let's now understand how Smolagents executes actions directly in code. In an agentic system, an action is any task that an AI agent performs, whether it's retrieving data, executing code, making API calls, or interacting with external tools. Most agentic frameworks handle actions using a two-step process. The LLM generates a request in a structured format, often in JSON. And that request is parsed and then executed by a separate process. Smolagents eliminates this extra step by allowing the LLM to directly write and execute Python code. This means that instead of formatting its actions in JSON, the agent simply generates runnable code that can be executed instantly. Let's look at an example. Say we have an agent that needs to calculate the sum of a list of numbers. With Smolagents, the agent directly generates the Python code like this. Numbers equals 1, 2, 3, 4, 5. Result equals sum of numbers. And print, result. The framework then executes this code immediately, and the result is available without needing any extra processing or interpretation. This is in stark contrast to how many other frameworks handle actions. While many agentic frameworks use a JSON-based approach to handling actions. Instead of generating executable code, the AI outputs JSON-formatted instructions that must be interpreted and converted into function calls before they can be executed. For example, in a JSON-based system, the agent might output something like this. Action, calculate _ sum. Parameters. Numbers, 1, 2, 3, 4, 5. Now, in order to actually perform this action, the system needs to first parse the JSON output to extract the action and parameters. Then match it to a predefined function, in this case, calculate _ sum. And manually execute the corresponding function with the given parameters. This extra processing step introduces latency, complexity, and potential points of failure. If the JSON is formatted incorrectly or an unexpected parameter is missing, the system may fail to execute the action properly. With Smolagents, none of this extra work is necessary. The LLM simply generates Python code that runs immediately. This makes the framework faster, simpler, and easier to debug compared to JSON-based systems. So why does Smolagents use a code-first approach instead of JSON? There are several key benefits such as no need for parsing or extra processing. With JSON-based frameworks, you need an additional layer of logic to parse, interpret, and execute actions. This adds complexity and increases the chances of errors. With Smolagents, the agent outputs code that can be executed immediately, making the process much more efficient. More transparency and debugging control. Since Smolagents generates actual Python code, developers can see exactly what the agent is doing. If something goes wrong, you can simply inspect the generated code and adjust it as needed. In a JSON-based system, errors can be harder to trace because the action must go through multiple processing steps before execution. And it gives more flexibility for developers. A code-first approach gives developers more control over how actions are executed. Since the output is standard Python, you can modify or extend the generated code before running it. Or manually test the output in a Python environment. and easily integrates Smolagents with existing Python applications. Since there's no JSON parsing or function matching step, Smolagents executes actions instantly. This is especially important for real-time applications, where reducing processing time can significantly improve performance. By eliminating the need for JSON-based action formatting, Smolagents reduces the number of steps where things can go wrong. Like, no need to handle JSON formatting issues. Or no need to write extra logic to parse tool calls. And no risk of JSON misinterpretation leading to incorrect function execution. In short, a code-first approach keeps things simple, transparent, and efficient, which is exactly why Smolagents uses it. Even though a code-first approach is often more efficient, there are some cases where JSON-based actions might be preferable, like if you're working in a non-Python environment. Since Smolagents generates Python code, it's best suited for Python-based applications. If you need a framework that works across multiple programming languages, JSON might be a better fit. Or if you need strict action validation. Some systems require a more structured, predefined way of handling actions to ensure strict compliance with business rules. JSON allows for more controlled execution, at the cost of additional complexity. Or if you want to integrate with external services that require structured data. Some APIs and tools work better with JSON-based interactions rather than executable code. By allowing AI agents to generate and execute Python code directly, Smolagents makes action execution simpler, more efficient, and more developer-friendly. Now that we understand how Smolagents executes actions using a code-first approach, let's explore the different types of agents within the framework. Smolagents supports three main types of agents, each designed for different kinds of tasks such as multi-step agents. These agents operate step by step, making decisions and executing one tool call at a time. The code agents. These agents generate and execute Python code to perform tasks. And the tool calling agents. Unlike code agents, these agents output JSON-based tool calls instead of direct code execution. Each of these agent types has its own strengths and use cases. Let's break them down one by one. The first and most fundamental type of agent in Smolagents is the multi-step agent. These agents follow a structured process where they think to decide what action to take based on the current task. Observe to gather necessary information, including previous results. And act to call a tool or function to execute the next step. This thought, observation, action cycle is repeated for each step until the task is complete. So, how multi-step agents work. Imagine we have an AI assistant that needs to plan a trip. A multi-step agent might follow this workflow. Step 1, the agent thinks about what's needed for the trip. Thought, I need to find the best flight options first. Action, calls a flight search tool. Step 2, it observes the flight search results and decides the next step. Thought, now that I have flight options, I should check hotel availability. Action, calls a hotel booking tool. Step 3, it processes all gathered information and finalizes recommendations. Thought, now I can summarize the best options for the user. Action, returns a structured travel itinerary. Each step consists of one thought and one tool call, ensuring that the AI makes incremental, controlled decisions rather than trying to solve everything at once. This makes multi-step agents ideal for complex workflows that require sequential reasoning, such as research assistants that gather and analyze information step by step. Or AI assistants that break down large tasks into smaller actions. Or a task automation bots that interact with multiple tools in a structured way. Let's now talk about the code agents. So while multi-step agents focus on structured decision-making, code agents take things a step further by generating and executing Python code. Instead of producing structured JSON output or predefined tool calls, a code agent directly writes Python code that can be run immediately. How code agents work. Let's say we have a code agent designed to help with data analysis. If a user asks, Can you calculate the average of this dataset, 10, 20, 30, 40? A code agent might generate and execute the following Python code like data equals 10, 20, 30, 40. Average equals sum of data, divided by len of data. And in last print, average. This code is directly executable, meaning there's no need for additional parsing or interpretation. The framework runs the code immediately and returns the result to the user. So, why to use code agents? Because it is great for automation and scripting, the code agents can perform tasks like data processing, or running calculations, or file manipulation. It simplifies execution. Instead of relying on pre-built tool functions, code agents can write their own logic dynamically. And provides flexibility. Since code agents generate plain Python code, developers can modify, test, or debug the generated code manually if needed. This makes code agents particularly useful for AI assistants that need to write, debug, and execute code on demand, such as AI coding assistants that generate and run scripts, or research tools that analyze data programmatically, or finance bots that calculate trends using Python-based tools. If you need an agent that can write and run Python code dynamically, code agents are the best choice in Smolagents. Let's now talk about the tool calling agents. So, unlike code agents, tool calling agents do not generate Python code directly. Instead, they produce structured tool calls in JSON format, which another system must then process and execute. How tool calling agents work? Let's say a user asks an AI agent, "What's the current temperature in New York?" A tool calling agent might generate this JSON output. Action is to get_weather. And in the parameters, the location is New York. This JSON output is then sent to an external tool, which processes the request and returns the result. So, why to use tool calling agents? Because it is good for systems that require structured outputs, because some applications need well-defined JSON outputs rather than Python code. It provides better for API-driven workflows. If your system integrates with APIs that expect JSON requests, a tool calling agent might be a better fit. And it is easier to control and validate. JSON-based tool calls can be strictly formatted, reducing the chances of execution errors. However, because JSON-based tool calls require an additional processing step, they are often slower and more complex compared to code agents, which execute actions directly. Tool calling agents are useful when working with web-based APIs that expect structured requests, or systems where security constraints prevent direct code execution, or workflows that require action validation before execution. If your AI agent needs to communicate with external services that process structured requests, tool calling agents are a good choice. Each agent type is designed to handle different kinds of tasks, giving developers the flexibility to build custom AI agents tailored to their specific needs. So, how tools work in Smolagents? Now that we understand the different types of agents in Smolagents, let's explore one of the most critical aspects of any agentic system, and they are tools. In Smolagents, tools are the building blocks that allow agents to interact with the world. Without tools, an agent is just a language model generating text. Tools give it the power to take action, whether that means searching the web, running calculations, or interacting with an API. In Smolagents, tools are essentially Python functions that an agent can call when needed. The framework provides two main ways to define tools. 1. Using the @tool decorator. And second, using the tool class. The easiest way to create a tool in Smolagents is by using the @tool decorator. This allows us to turn any Python function into an agent-accessible tool with minimal effort. Let's look at an example. Suppose we want to create a tool that fetches the current weather for a given location. Let's break this down step by step. In this example, we're defining a simple weather fetching tool using the @tool decorator. So, let's look at the code. In step 1, the first thing we're doing here is importing the tool decorator from Smolagents. Now, what does a decorator do? Think of it as a label that tells Smolagents that this function is a tool that agents can use. By adding this decorator, we're making sure that our function is recognized and accessible by AI agents within the Smolagents framework. Step 2, defining the tool function like @tool. Def get weather, location, string, dash a string. Now, here's the function itself, where we're using @tool to mark this function as an AI accessible tool. The function is called get_weather, and it takes one parameter, location, which is a string. It's also using type hints, -str, meaning this function is expected to return a string as output. In simple terms, this function is designed to take in a location, like New York or London, and return a weather update for that place. In step 3, we define function logic by simulating a weather response. Return f. The weather in a location is 25 degrees Celsius and sunny. The function is returning a formatted string that tells us what the weather is like in the given location. The location part is a placeholder, meaning if you pass New York, the function will return. The weather in New York is 25 degrees Celsius and sunny. Now, you might be wondering, where is this function actually fetching real weather data from? Well, it's not. Right now, it's just returning a fixed response as a placeholder. In a real-world scenario, you'd likely want this function to connect to an actual weather API, something like OpenWeather or Weather API, to fetch live weather updates. But for now, we're just keeping it simple. So, let's imagine you have an AI assistant built with Smolagents, and a user asks, "Hey, what's the weather like in Paris?" Here's what happens behind the scenes. The AI agent recognizes that it needs weather data. It calls our get_weather function, passing Paris as the location. The function returns the response. The weather in Paris is 25 degrees Celsius and sunny. The AI then sends this response back to the user. From the user's perspective, it feels like they're talking to a smart AI that knows the weather, when in reality, it's just calling our tool function. Now we will look into using the tool class. While the @tool decorator is the simplest way to define a tool, Smolagents also provides a more structured way using the tool class. Here's the same weather fetching tool, but this time using the tool class. This approach gives us more control over how the tool is registered and used. Let's break it down. Step 1, from Smolagents import tool. Here, we're importing the tool class from Smolagents. Unlike the @tool decorator, which automatically registers a function as a tool, the tool class lets us manually create a tool object. This gives us more flexibility, especially when we need to dynamically register tools or add extra metadata. Step 2, defining the function. Def fetch_weather, location, str-str, fetches the weather for a given location. Return f. The weather in a location is 25 degrees Celsius and sunny. This is a simple Python function that takes a location as input and returns a weather update in the form of a string. Just like before, this function isn't actually fetching real weather data, it's just returning a placeholder response. But the key thing to notice here is that this function is not yet a tool. To make it a tool, we need to wrap it inside a tool object, which brings us to the next part. Step 3, creating a tool object. Weather_tool equals tool. Name equals get_weather. Description equals fetches the weather for a given location. Func equals fetch_weather. Here's what's happening in this step. We're creating a new tool and storing it in weather_tool. The tool class takes 3 parameters, name, get_weather, this is the tool's identifier. Description, fetches the weather for a given location. A human-readable description of what this tool does. And func fetch_weather, this tells Smolagents which function should be called when the tool is used. By wrapping fetch_weather inside a tool object, we're telling Smolagents, this is an official tool that AI agents can use. How this works in an AI agent: let's say we have an AI assistant that needs to answer weather-related questions. A user asks, "What's the weather like in Tokyo?" The AI agent identifies that it needs weather data and calls our tool function, and the function runs and returns, "The weather in Tokyo is 25 degrees Celsius and sunny." And the AI sends this back to the user as a response. So, you might be wondering, why would we use the tool class instead of the simpler tool decorator? Here are some reasons. It provides more control. You can dynamically register tools based on conditions. It is easier to modify. You can update tool properties without changing function code. And it has better organization, useful when managing multiple tools in a structured way. Whether you use the tool decorator or the tool class, both approaches allow agents to seamlessly interact with external functions, making them more capable and dynamic. Let's now understand the model integration in Smolagents. In this session, we're going to explore how Smolagents integrates with different large language models, LLMs. Unlike some frameworks that lock you into a specific provider, Smolagents is designed to be flexible, allowing developers to choose the model that best fits their needs. At its core, Smolagents is designed to be LLM agnostic. This means that instead of relying on a single AI provider, it allows developers to plug in any large language model that meets a basic set of integration requirements. To work with Smolagents, an LLM must be callable. The model must accept a text input and return a text output. And support API or local execution. It should either be accessible via an API, like OpenAI's GPT models, or be runnable locally, like Hugging Face transformers. And handle tool execution. The model should be capable of generating responses that include tool calls, allowing the agent to take actions. Because Smolagents follows this callable model approach, it can integrate with virtually any LLM, giving developers maximum flexibility in choosing a model. One of the biggest advantages of Smolagents is that it doesn't force you to use a specific LLM provider. You can choose to run models locally on your own hardware. Or use cloud-based APIs like OpenAI, Hugging Face, or Azure. Let's break down these two options. First, we will look into the running local models with Smolagents. So, the developers who want full control over their AI models, Smolagents supports locally hosted models using libraries like Hugging Face transformers. Let's go step by step through this code and understand how it loads and interacts with a locally hosted LLM using Hugging Face transformers library. Step 1. Importing the required library. From Transformers Import Pipeline. Here, we're importing the pipeline function from the Transformers library. The pipeline function is a high-level API that makes it easy to use pre-trained AI models without writing a lot of extra code. And it allows us to load and run models locally, meaning the AI is running entirely on your machine, no external API calls needed. This is useful when you want full control over the model and data privacy. And you don't want to rely on cloud-based AI services like OpenAI. Or you have the necessary hardware, because large models require significant computing power. Step 2 is loading the local model. Local_model equals pipeline, text generation, model equals metalama/llama 2-7b. Here's what's happening in this line. We're creating a pipeline for text generation, meaning this model will generate responses to user input. The model we're using is metalama/llama 2-7b, which is a 7 billion parameter version of Llama 2, a popular open-source LLM developed by Meta. This model will be downloaded and stored locally the first time you run this code. Running this model requires significant GPU resources. If you're on a standard laptop without a dedicated GPU, performance may be slow. Step 3 is about defining a function to interact with the model. Def call_local_model, prompt, str-str. Now, we're defining a function called call_local_model. It takes one input parameter, prompt, which is a string containing the user's question or request. And the function will send this prompt to the local model and return the AI-generated response. Step 4 is generating a response from the LLM. Response equals local_model, prompt, max_length equals 200. Let's break this down. The local_model, prompt, max_length equals 200, sends the user's prompt to the model and asks it to generate a response. The max_length equals 200 means the response will be limited to 200 tokens, to prevent extremely long outputs. And the model outputs a list of responses, and we're capturing that list in the response variable. Step 5 is returning the AI's response. Return response, 0, generated_text, since the output is a list, we're extracting the first response using response, 0. And the actual AI-generated text is stored inside, generated_text, so we return that as the function's output. There are several reasons why running a local model like this might be a better choice than using a cloud-based AI model, like OpenAI's GPT-4, such as data privacy. Since everything runs on your machine, no data is sent to external servers. No API costs. Many cloud-based LLMs charge per API call, but running a local model is free after the initial download. Customization, you can fine-tune the model on your own data to improve its responses for specific tasks. And offline access, you can use the model without an internet connection, making it useful for secure or remote environments. However, there are also some downsides, like it requires strong hardware. Large models like Llama 2-7B need a powerful GPU, ideally with at least 16 GB of RAM, to run efficiently. It is slower than cloud AI. If you don't have high-end hardware, response times may be significantly slower than cloud-based APIs. And storage space, these models take up a lot of disk space. Llama 2-7B alone requires several gigabytes. This is a powerful way to use AI while maintaining privacy, cost efficiency, and offline access. Next, we will take example of using cloud-based models via APIs. For developers who prefer cloud-based AI services, Smolagents also integrates with popular LLM APIs like OpenAI, GPT-4, GPT 3.5, etc., or Hugging Face Inference API, or Azure OpenAI, or other third-party AI services. Alright, let's break this down step by step. This function is designed to send a prompt to OpenAI's GPT model via API and return the response. Essentially, it allows us to interact with an AI model just like ChatGPT. Step 1, we will import the OpenAI library with command import OpenAI. This allows us to connect to OpenAI's servers and send requests to their AI models. If you don't have this installed yet, you'll need to run pip install OpenAI. This makes sure you have the required package to work with OpenAI's API. Step 2, defining the function. Def call_OpenAI_model, prompt, str-str. Here, we're defining a function called call_OpenAI_model. It takes one argument, prompt, which is the text input that we want to send to the AI. And the function is set to return a string, meaning the AI's response will be text-based. Step 3, sending a request to OpenAI's API. Response equals OpenAI.chatCompletion.create. Model equals GPT-4. Messages equals role, user, content, prompt. This is the key part. Let's go over what's happening here. OpenAI.chatCompletion.create, this is the function that sends a request to OpenAI's API and asks GPT-4 to generate a response. Model equals GPT-4, this tells OpenAI which AI model we want to use. Here, we're using GPT-4, but we could switch it to GPT 3.5 Turbo if we wanted a faster and cheaper response. Messages, this is where we define the conversation format. Now, OpenAI's API is designed for chat-based interactions, so it expects a structured conversation history. In our case, we're sending just one message, where role, user, indicates that this is the user's message. And the content, prompt is the actual text input that we want the AI to respond to. Step 4. Extracting and returning the response. Return response, choices, 0, message, content. So, what's happening here? OpenAI's API returns multiple choices, but we only need the first response, so we access it using choices, 0. Inside this response, we extract the AI-generated message using message, content. Finally, we return this text back to the user. So, when this function is called, it sends a prompt to OpenAI, gets the response, and returns it as a clean text output. For example, how this works in action. Let's say we call the function like this. Print, call_OpenAI_model, what are the benefits of AI? What happens? The function sends the text, what are the benefits of AI, to OpenAI's GPT-4 model. GPT-4 processes the request and generates a response. The API sends back a structured response and our function extracts the AI's response and returns. And that's what gets printed to the screen. This is how cloud-based model can now be used in Smolagents. Cloud-based models are a great choice when you need access to the latest AI models with state-of-the-art capabilities. Or you don't have the hardware to run large models locally. Or you want scalability, allowing the system to handle multiple requests at once. With Smolagents, switching between local and cloud-based models is seamless, allowing developers to choose the best approach for their needs. One of the key decisions when working with AI models is choosing between running a model locally on your own hardware or using a cloud-based AI service. Both options have their strengths and weaknesses, and the right choice depends on what you need for your project. Let's break it down and compare them so you can decide which one works best for you. Speed, how fast do you need responses? Local models are generally faster for immediate responses because they run directly on your machine. There is no delay from sending requests over the internet, making them ideal for real-time applications like chatbots or personal assistants that need to respond instantly. Cloud-based models, on the other hand, involve sending data to an external server where the AI processes it before sending a response back. This can introduce a slight delay, especially if there is a slow internet connection. However, cloud providers optimize their systems for speed, so in most cases, the delay is minimal. Cloud-based AI is also better suited for handling large volumes of requests at once because it can allocate additional resources as needed. If real-time performance is your top priority, local models are the way to go. If scalability is more important, cloud-based models will serve you better. Privacy, where does your data go? With a local model, all of your data stays on your machine. This means no external servers are involved, which is a huge advantage if you are working with sensitive information. Industries like healthcare, finance, and legal services often prefer local models for this reason. Keeping everything in-house ensures that private data remains secure and does not require additional compliance checks. With a cloud-based model, your data is sent to external servers for processing. While cloud providers have strong security measures in place, some organizations may still have concerns about compliance with regulations like GDPR or HIPAA. If privacy is your main concern, a local model gives you full control over your data. However, if security compliance is already covered and you need the convenience of cloud-based AI, then using an API-based model is still a strong option. Cost, one-time investment versus pay-as-you-go. Running a model locally requires an upfront investment in powerful hardware. If you are using large AI models, you need a strong GPU, and that can be expensive. The good news is that once you have the hardware, you do not need to pay ongoing fees to use the model. Cloud-based models, on the other hand, do not require any special hardware on your end. You simply send a request to an AI provider like OpenAI or Hugging Face and pay based on how much you use. This is a great option if you want to avoid the high initial cost of buying hardware. However, over time, these per-use charges can add up, especially if your application scales. If you have the budget for hardware and plan to use AI frequently, a local model can save money in the long run. If you want to start quickly with lower initial costs, a cloud-based model is a better choice. Model availability: which AI models can you use? Local models are limited to open-source AI models like Llama, Mistral, and Falcon. These models have improved significantly, but they are still not as advanced as proprietary cloud-based models like GPT-4 or Google's Gemini. Fine-tuning open-source models is an option, but it requires technical expertise. Cloud-based models give you access to the latest and most powerful AI systems. This means you can work with cutting-edge technology without needing to install or maintain anything on your machine. If you need access to the best AI available, cloud models are the better choice. If open-source models are good enough for your needs and you prefer to have full control, a local model is a solid option. Scalability: can it handle growth? Local models are limited by your hardware. If your computer or server reaches its maximum capacity, you cannot process more requests unless you upgrade your system. This makes local models best suited for personal use or small-scale applications. Cloud-based models, on the other hand, are designed to handle high volumes of requests. Whether you are processing one request or a million, cloud AI can allocate more computing power as needed. This makes cloud-based AI the preferred option for businesses and applications that need to scale. If your project is small and will not need to handle large amounts of traffic, a local model is fine. If you expect your application to grow, cloud-based AI will allow you to scale effortlessly. Which one should you choose? If you need fast, real-time performance and complete control over your data, a local model is the best option. It is also a good choice if you are willing to invest in hardware and want to avoid ongoing costs. If you need access to the most advanced AI models, want to start quickly without hardware costs, or need to scale easily, then a cloud-based model is the better choice. Many projects benefit from a combination of both approaches. You can run a local model for privacy-sensitive tasks while using cloud-based AI for more complex reasoning and scalability. It all depends on what works best for your specific needs. Now, let's take a look at the predefined model classes that Smolagents provides to make this integration easier. Instead of manually writing API calls or loading models from scratch, Smolagents offers built-in model classes that streamline the process. These predefined classes allow you to quickly connect your agent to a wide range of LLMs, whether they're running locally on your machine or hosted on cloud-based APIs. Each of these classes is designed to simplify model integration, making it easy to swap between different AI providers without changing your core application logic. Let's break them down one by one. 1. Transformers Model for local integration. The Transformers Model class is a tool that allows you to run large language models, or LLMs, directly on your own machine using the Hugging Face Transformers library. Unlike cloud-based AI models that require an internet connection and an API key, this approach lets you work completely offline. When you use this model class, it loads an LLM onto your system, so instead of sending requests to an external server, everything happens locally. This means once the model is downloaded, you have full control over it. You don't have to worry about sending sensitive data to the cloud, and you avoid any usage fees that come with pay-per-use APIs. The process is simple. You select a model, download it from Hugging Face, and then your system is ready to generate responses just like an online AI model would. This is especially useful if you want to fine-tune the model, experiment with different versions, or build applications that don't rely on an internet connection. Running AI locally does require a capable computer, especially if you are working with larger models, but it gives you flexibility, security, and long-term cost savings. Best use cases are like, when privacy is important, and you don't want to send data to external APIs. Or when you need low-latency responses without waiting for API calls. Or when working offline or in secure environments where external API access is restricted. If you want complete control over your model and data, Transformers model is the best choice. 2. HFAPI model, serverless inference with Hugging Face. The HFAPI model class is a great option for running AI models without needing to install them on your own machine. Instead of relying on local hardware, this approach connects to the Hugging Face API, where powerful AI models are hosted and ready to use. This is known as serverless inference, which means the heavy computational work happens on remote servers rather than on your device. This is especially useful if you don't have the hardware required to run large language models locally. High-end AI models often need powerful GPUs and a lot of memory, which can be expensive and difficult to set up. By using the Hugging Face API, you can access state-of-the-art models on demand without any installation or maintenance. Another key advantage is scalability. If you are working on an application where multiple agents need to process AI queries at the same time, a cloud-based approach ensures that performance remains smooth. Since the API handles the processing, you don't have to worry about overloading your own system. This makes HFAPI model an ideal choice for developers who want quick access to a wide variety of AI models without dealing with infrastructure. Whether you need natural language processing, text generation, or even vision-based AI, this approach allows you to experiment with different models effortlessly while letting the cloud handle the heavy lifting. 3. Light LLM model, lightweight API interactions. The Light LLM model is designed to make it easy for Smolagents to interact with different AI models through a single, unified interface. Instead of being locked into just one AI provider, this lightweight wrapper allows developers to switch between multiple language models without changing their code. This is especially useful when flexibility is a priority. For example, you might want to test different AI models to see which one performs best for your specific use case. With Light LLM model, you can seamlessly switch between providers like OpenAI, Anthropic, Hugging Face, or other LLM APIs without rewriting your application's logic. Another key advantage is cost management. Since different AI providers have different pricing structures, Light LLM allows you to optimize API usage by selecting the most cost-effective model for your needs. If one provider raises prices or another offers better performance at a lower cost, you can adjust your setup with minimal effort. This approach is also ideal when working on applications that need multiple AI models at the same time. Instead of setting up complex integrations for each provider separately, Light LLM simplifies the process by handling all the interactions under one system. This makes it a great tool for developers who want maximum flexibility and efficiency when integrating AI into their projects. 4. OpenAI Server Model, connecting to OpenAI's GPT models. The OpenAI Server Model class is built specifically for working with OpenAI's GPT models, such as GPT 3.5 and GPT 4. It provides an easy way for Smolagents to integrate these powerful AI models into applications without requiring any complex setup. Since OpenAI's models are some of the most advanced available, this class ensures that developers can access high-quality responses for a wide range of tasks. One of the biggest advantages of using this model is its ability to handle natural language with exceptional fluency and reasoning. Whether you're developing a chatbot, conducting AI-assisted research, or generating high-quality content, OpenAI's models provide reliable and well-structured outputs. This is also a great option if you want a cloud-based AI solution that is both scalable and well-supported. Since OpenAI continuously improves its models and infrastructure, you benefit from regular updates and optimizations without having to worry about managing the hardware yourself. If your application relies on GPT-4's reasoning abilities, language understanding, or creative text generation, this model class is the best choice. It provides a seamless connection to OpenAI's API, allowing you to focus on building your application while leveraging state-of-the-art AI. 5. Azure OpenAI Server Model, connecting to Azure OpenAI services. The Azure OpenAI Server Model is designed for organizations that want to use OpenAI's models but within Microsoft Azure's infrastructure. Instead of connecting directly to OpenAI's API, this model allows businesses to access the same powerful AI models, such as GPT-4, but through Azure's cloud platform. This is especially useful for enterprises that already rely on Microsoft's ecosystem and need a seamless way to integrate AI into their workflows. One of the key advantages of using Azure's AI infrastructure is enhanced data privacy and compliance. Many organizations, especially in industries like finance, healthcare, and government, have strict regulations around data security. By hosting OpenAI's models within Azure, businesses can ensure that they meet industry-specific compliance standards while still benefiting from cutting-edge AI capabilities. Another major benefit is the ability to integrate AI with existing Azure services, such as Azure Machine Learning, Azure Cognitive Services, and enterprise-level security tools. This makes it an ideal choice for companies that need AI-powered applications but prefer to manage everything within the Azure environment. If your organization is already using Microsoft Azure and you want access to OpenAI's models with enterprise-level security and compliance, this is the best model class to use. It provides the reliability and power of OpenAI's models while keeping everything within a trusted enterprise cloud infrastructure. To summarize, Smolagents provides 5 predefined model classes, each suited for different needs. The Transformers model is best for local models using Hugging Face transformers. The HFAPI model is best for serverless inference via Hugging Face's cloud API. The Light LLM model is best for flexible API-based model selection. The OpenAI Server model is best for direct OpenAI API integration. And the Azure OpenAI Server model is best for enterprise AI applications using Azure. These predefined classes make it easy to integrate AI models into Smolagents, allowing developers to focus on building intelligent AI agents rather than managing infrastructure. Let us now discuss about the advanced capabilities in Smolagents, Retrieval agents. As we move into the advanced capabilities of Smolagents, one of the most powerful features we'll explore is Retrieval agents. These agents go beyond standard language models by integrating with knowledge bases, vector stores, and external data sources to improve accuracy and provide more informed responses. Let's dive in. How Smolagents integrates with knowledge bases. A standard LLM generates responses based on its training data, but this data is static as it doesn't change after training. This means that if you ask an LLM about recent events or proprietary company data, it won't have up-to-date information. This is where retrieval agents come in. So, what is a retrieval agent? A retrieval agent is an AI system that searches an external knowledge base such as documents, databases, APIs, and finds the most relevant information based on the query, and uses that information to generate a more accurate response. Instead of relying only on its training data, the agent can retrieve fresh, relevant information and incorporate it into its answer. For example, a research assistant AI. Let's say we're building an AI that answers medical questions. If a user asks, "What are the latest treatments for Alzheimer's?" a standard LLM might give a generic answer based on its pre-existing knowledge. Whereas a retrieval agent, however, would search a medical knowledge base for the latest research papers, and retrieve relevant articles from scientific journals, and summarize new findings to provide an up-to-date answer. This makes retrieval agents far more powerful than standard LLMs, especially in fields where accuracy and real-time knowledge retrieval are critical. To make retrieval agents work efficiently, Smolagents leverages vector stores and retrieval-augmented generation. So, what is a vector store? A vector store is a specialized database that helps AI search and retrieve information efficiently. Instead of storing data as traditional text, it converts words, sentences, or entire documents into mathematical vectors. This allows the AI to perform semantic searches, meaning it can find relevant information even if the wording is different. How a vector store works: imagine we have a knowledge base containing two documents, then AI can be used for cancer diagnosis. And the machine learning helps detect tumors in patients. So, if a user asks, how does AI help in cancer detection? A keyword-based search might fail because the words don't match exactly. But a vector store understands that cancer diagnosis and tumor detection are related, so it retrieves both documents. This makes vector stores incredibly useful for AI applications that need deep information retrieval. And what is Retrieval Augmented Generation, or RAG? The Retrieval Augmented Generation is a technique that combines LLM-generated text based on what the AI already knows, and retrieved knowledge from external sources based on what the AI finds in a vector store. This ensures that AI-generated responses are grounded in real, up-to-date information rather than relying solely on pre-trained data. For example, how RAG works in Smolagents. If a user asks, "What is the latest research on climate change?" a standard LLM might only generate a general answer based on outdated training data. Whereas a retrieval agent using RAG would search a vector store containing climate change research papers and retrieve the most relevant articles published recently, and combine that information with the LLM's existing knowledge to create a more complete response. This is especially useful in applications like legal AI assistance for retrieving case law updates, or customer support bots for fetching real-time product information, or market analysis tools based on gathering the latest financial trends. So, why retrieval agents matter in AI applications? So why is retrieval so important? Here's what makes retrieval agents a game changer: increases accuracy as AI no longer relies only on pre-trained knowledge. It can fetch real-world data for better responses. Keeps information up to date. The LLMs don't have real-time knowledge, but retrieval agents can pull the latest information. And enhances credibility as AI-generated answers are more reliable when backed by real, verifiable sources. Makes AI more interactive as users can ask more complex, information-heavy questions, and the AI can find the right answers. Whether you're building an AI-powered assistant, a legal research tool, or an enterprise knowledge bot, retrieval agents significantly improve the quality and reliability of AI responses. Multi-agent systems in Smolagents. As we continue exploring the advanced capabilities of Smolagents, one of the most powerful techniques we can use is multi-agent systems. Instead of relying on a single AI agent, we can combine multiple agents, each with its own specialized role, to create a more capable and intelligent system. Why orchestrating multiple agents is useful, as we all know that a single AI agent is often limited to one type of task. It might be great at answering questions, writing code, or retrieving data, but it can't always handle complex, multi-step processes on its own. By orchestrating multiple agents, we can break down complex tasks into specialized roles, allowing each agent to focus on what it does best. And we can improve efficiency and scalability. Agents can work in parallel to speed up responses and enhance decision-making. One agent can retrieve information while another processes it, leading to more accurate results. Instead of forcing a single agent to handle everything, we can assign different responsibilities to multiple agents and coordinate their actions like a team. Imagine you're building an AI research assistant that finds research papers and summarizes key points and generates a list of citations. A single agent might struggle to do all of this efficiently. Instead, we can create 3 separate agents: a retrieval agent which searches for relevant research papers, a summary agent who reads and summarizes key points, and a citation agent who formats the sources in proper citation style. By having these agents work together, we create a system that is faster, more organized, and more accurate than a single agent doing everything. Now that we understand why multi-agent systems are so useful, let's talk about how different types of agents can work together to create more powerful AI applications. Instead of relying on a single agent to do everything, we can combine retrieval, code execution, and tool calling agents to make AI more efficient and capable. Combining retrieval and code execution agents. One common combination is using a retrieval agent with a code execution agent. This is especially useful for tasks like data analysis, financial modeling, or research, where raw information needs to be processed before it becomes meaningful. For example, let's say we want to build an AI-powered stock market analyst. The retrieval agent's job is to search for the latest stock data, while the code execution agent processes the numbers and determines trends. If a user asks about the current trend of a particular stock, the AI system first fetches the latest stock price, then runs a Python-based analysis to predict whether the stock is trending up or down. Finally, the AI presents a clear, data-driven response to the user. By combining retrieval and code execution, the AI does not just provide general information but also generates real-time insights based on fresh data rather than relying on outdated knowledge. Combining retrieval and tool calling agents. Another useful combination is a retrieval agent working alongside a tool calling agent. This setup is great for situations where AI needs to interact with external systems, such as booking services, customer support platforms, or APIs. Consider an AI travel assistant that helps users find and book flights. The retrieval agent searches for available flights and hotel prices, while the tool calling agent takes action, such as making a reservation through an external API. When a user requests the cheapest flight to a specific destination, the retrieval agent finds the best option and hands it over to the tool calling agent, which completes the booking and confirms the details with the user. This combination allows AI to move beyond just providing information. It can search for relevant data and then act on it, making applications much more useful in real-world scenarios. Combining retrieval, code execution, and tool calling agents. For even more advanced AI applications, all three types of agents, retrieval, code execution, and tool calling, can work together. This creates a system that can find information, analyze it, and take action based on the results. Imagine a law firm that wants an AI legal assistant to help with case research. The retrieval agent searches legal databases for relevant cases, the code execution agent analyzes court rulings to find patterns, and the tool calling agent drafts a legal argument in a structured format. The lawyer does not just receive a list of case references but gets a well-organized legal document ready for review. By combining these agents, AI can not only search for and process data but also generate structured outputs, saving time and improving accuracy. Why multi-agent systems matter? The power of multi-agent systems comes from their ability to divide complex tasks into specialized roles. Instead of having one agent handle everything, multiple agents work in parallel, improving efficiency and accuracy. With a retrieval agent focused on gathering information, a code execution agent dedicated to processing data, and a tool calling agent taking action, AI applications become faster and more scalable. This setup also allows systems to grow and adapt over time by adding new capabilities without redesigning the entire framework. Multi-agent systems allow developers to build AI that is more capable, scalable, and accurate. By combining retrieval, code execution, and tool calling agents, we can create AI applications that go beyond simple question answering and actively generate, analyze, and apply information. With this approach, AI is no longer just responding to requests but is actively working as an intelligent assistant, making decisions and performing actions based on real-world data. This is what makes multi-agent systems such a powerful tool in AI development. So far, we've explored how Smolagents can handle text-based tasks using retrieval agents, code execution, and multi-agent systems. But what if we want our AI to process images or interact with web pages? That's where vision agents and browser agents come into play. These agents allow Smolagents to work beyond just text, giving AI the ability to analyze images, extract information from the web, and interact with online content. Understanding vision language models and browser agents. Artificial intelligence has traditionally been focused on processing and understanding text. However, with advancements in multimodal AI, models can now see, analyze, and understand images and web content in addition to processing text. This brings us to two powerful types of AI agents, vision agents and browser agents, which expand the way AI interacts with the real world. What are vision language models? A vision language model, or VLM, is an advanced AI system that can process both text and images. Unlike traditional language models that work only with words, VLMs combine computer vision with natural language understanding to interpret images and generate meaningful responses. VLMs can perform a variety of tasks, including describing images by generating captions, or identifying objects and patterns in pictures, or answering questions based on visual content. For example, imagine uploading a picture of a damaged car and asking, "What's wrong with this car?" A VLM-powered vision agent can analyze the image and respond, "The front bumper is dented, and the left headlight is broken." This works because the AI can recognize the objects in the image, identify the damage, and explain it in natural language. Several open-source VLMs are available today, including Blip2, which generates descriptions and answers questions about images. LLavier, which integrates visual understanding with a language model. GPT-4V, a multimodal version of GPT-4 that combines text and image reasoning. These models make it possible for AI to process images in a way that mimics human perception, allowing for smarter and more interactive applications. How vision agents work in Smolagents. Now that we understand what VLMs do, let's look at how vision agents use them in real-world applications. A vision agent is an AI system that can analyze images and extract meaningful information, or can recognize objects, patterns, and even text within images, and combine visual and text-based reasoning to generate useful insights. The process typically works in 3 steps. 1. The agent receives an image, either uploaded by a user or retrieved from the web. 2. The VLM analyzes the image and extracts relevant information. 3. The agent combines visual and text-based reasoning to generate a response. Let's consider a few real-world examples. AI for medical image analysis. A doctor uploads a chest X-ray and asks, "Does this X-ray show signs of pneumonia?" The vision agent processes the image and responds, "Yes, the image shows lung opacity, which is a sign of pneumonia. You should consult a radiologist for further evaluation." AI for manufacturing defect detection. A factory worker takes a photo of a defective product and asks, "What's wrong with this part?" The vision agent analyzes the image and responds, "There is a visible crack on the left side of the metal casing." These examples show how vision agents can assist in real-world decision-making by combining visual recognition with language-based reasoning. What are browser agents? While vision agents help AI process and understand images, browser agents allow AI to interact with web content, helping extract, analyze, and navigate online data. A browser agent can extract information from web pages, including text, images, and tables, or follow links and navigate through multiple web pages, or summarize articles or scrape important data from websites. Unlike traditional AI models that rely on static knowledge, browser agents can access real-time information from the internet. This makes them extremely powerful for applications that require live data. Some examples of browser agents in action include real-time news aggregation, such as finding the latest AI developments from multiple sources, or product price comparison by scraping e-commerce websites to identify the best deals. Or job market analysis by collecting and summarizing job listings from different platforms. How browser agents work in Smolagents. A browser agent typically follows 3 steps. 1. It receives a URL or a search query from the user. 2. It scrapes and extracts relevant information from web pages. 3. It processes the data and generates a structured response. Let's look at a few real-world examples. AI News Summary Bot. A user asks, "What are the latest advancements in AI?" The browser agent searches for AI-related news articles and extracts key information from multiple sources and summarizes the most important updates. The AI then responds with a structured summary of the latest developments, such as, OpenAI releases a new version of GPT-4, or researchers at MIT develop a faster deep learning model, or Google introduces an AI-powered search algorithm. AI Travel Assistant using browser agents. A user asks, "Find the best flights from New York to Paris for next week." The browser agent scrapes travel websites for flight prices and finds the best deals available, and presents the user with the cheapest and most convenient flight options. The AI then provides a direct response, such as, "The best flight is a direct flight on Air France, departing at 7 p.m. for $500. Browser agents allow AI systems to find and process live information, making them ideal for real-time applications. Vision and browser agents in the real world. By integrating vision and browser agents, AI becomes much more than a text-based assistant. These agents can assist doctors in diagnosing medical conditions from images, help manufacturers detect product defects automatically, automate news and market analysis for journalists and researchers, provide real-time price tracking for shoppers and businesses, extract and summarize legal or research documents from the web. Traditional language models are limited to the information they were trained on, but vision and browser agents allow AI to see, read, and interact with real-world data in ways that text-based models cannot. Why vision and browser agents matter. Expanding AI beyond just text processing opens up many new possibilities. These advanced agents improve accuracy by retrieving and analyzing live information, automate research and data collection, saving users time, enhance AI interactivity, allowing it to process both visual and online content, enable multimodal AI applications that combine text, images, and web data. With these capabilities, AI can go beyond simple conversation and actively observe, analyze, and act on real-world inputs. Smolagents enables AI to go beyond text-based reasoning by integrating vision and browser agents into its framework. By leveraging vision language models for image analysis and browser agents for real-time web interaction, AI becomes more powerful, flexible, and useful in real-world applications. With these technologies, we can build truly multimodal AI applications, AI that can see, read, and interact with the world just like humans do. This marks an important step forward in making AI systems smarter, faster, and more capable than ever before. In the next session, we will dive into another powerful agentic framework called Llama Index. While Smolagents provided us with a lightweight, code-first approach to building AI agents, Llama Index takes a different path by focusing on efficient data retrieval and indexing for large-scale AI applications. With Llama Index, we will explore how to structure and organize data so AI models can access it efficiently, retrieve relevant information quickly using advanced indexing techniques, and enhance LLMs by connecting them with structured databases, APIs, and external knowledge sources. If you're looking to build AI applications that can process, store, and retrieve massive amounts of information while maintaining context, then Llama Index will be an essential tool to learn. In this session, we took a deep dive into Smolagents, a lightweight agentic framework designed to simplify AI agent development. Here's a quick recap of the key takeaways. Understanding agentic frameworks. Introduction to Smolagents. Key features of Smolagents. Model integration in Smolagents. Advanced capabilities in Smolagents. By the end of this session, we saw how Smolagents allows AI models to think, observe, and act, making them much more powerful than standard language models. In the next session, we will shift our focus to Llama Index, a framework designed to make AI applications smarter by giving them access to structured data. This will be particularly useful for anyone looking to build AI-powered research tools, knowledge assistants, or any system that requires fast and structured data retrieval. Get ready to explore how AI can be combined with structured knowledge to create even more intelligent applications. If you found this session helpful and want to keep learning about AI and agentic frameworks, make sure to like, share, and subscribe to our channel, the AI Academy. Your support helps us create more in-depth content on AI development, frameworks, and the latest advancements in artificial intelligence. Also, let us know your thoughts in the comments section. We'd love to hear your questions, feedback, and suggestions for future topics. Stay tuned for more exciting AI content, and we'll see you in the next session.